Okay, here's the application. Here is where we are going to solve word problems using systems of equations. Okay, so they're going to give us a word problem. And what you need to get out of every word problem, there are two things very important that you need to get. You need to identify two variables, and you need to write two equations. Okay, two variables, two equations. This is your goal for every problem, and then it will be something that we've done in Chapter 6 that you can solve. Okay? All right, so let's read this first problem. An algebra teacher drove by a farmyard full of chickens and pigs. This is sort of a classic word problem. You may have heard something like this before. The teacher happened to notice there were a total, that should be a total of 100 heads and 270 legs. How many chickens were there? How many pigs were there? Now, she's driving by a farmyard, and she happens to notice 100 heads, and 270 legs. She is one talented math teacher. She can count very quickly. But anyway, we're trying to figure out how many chickens, how many pigs, okay? So we need our two variables. What are the two things we don't know? We need a variable for chickens. So let's let C be the number of chickens. And we want to know how many pigs there are. So P is the number of pigs. Okay? So chickens and pigs are the two things we are trying to figure out. Now, there are two pieces of information they give us that are very important. So there were a total of 100 heads. Now, how do you figure out how many heads were in that farmyard? Well, there were chicken heads. I'm having trouble saying heads and legs together. There were pig heads, right? And when I put the chickens and pigs together, there are 100 of them. So basically that 100 heads means there's 100 animals out there. Some of them are chickens, some of them are pigs. Now, how do the legs come into play here? Well, how many legs do a chicken have, or does a chicken have? A chicken has 2 legs. So every chicken has 2 legs, right? And every pig has 4 legs. So if I add all the chicken legs up, every chicken has 2. And if I add all the pig legs up, every pig has 4. I get how many? 270 legs. There we go. All right, now this is a system of equation. Do you know how to solve this? You do. And guess what? You get to choose how to solve it. You could graph it if you wanted. I don't think I would. You can use substitution. You can use elimination. So I want you to pause the video and I want you to solve this. Remember, we want to know the number of chickens and pigs. Then turn it back on and we'll check your work.
Miss Awesome.
Okay, so I decided to solve by elimination. I multiplied my first equation by -2. I added. I got P was 35. I plugged that back into the first equation, and I got C was 65. So I got that there were 65 chickens and 35 pigs. Let's look at another one. Okay, here we have Moolah. Moolah has 24 coins that are all dimes and quarters. The value of the coins is $3.75. How many dimes and how many quarters does Moolah have? Remember, we need 2 variables and 2 equations. What are the 2 things we don't know? Well, we don't know how many dimes Moolah has, so we're going to let D be dimes. We don't know how many quarters he has, so let's let Q be quarters. Okay, so there's our 2 variables. Now, the 2 pieces of information that are going to give us our equations. 24 coins. How do we get his total coins? Well, we add up his dimes and his quarters. And when you put his dimes and quarters together, he has 24 coins, okay? Now, the value, that means how much it's worth. The value is $3.75. That's the next thing we're going to use. Now, watch carefully. What is a dime worth? 10 cents. So if I want to know how much money in dimes he has, I'm going to multiply the number of dimes by 10 cents, right? Now, typically that would mean a decimal. I'm going to ignore the decimal, and I'm just going to write 10D. And the reason I do that is because each dime is worth 10 cents. Now, how much is a quarter worth? A quarter is worth 25 cents. So, 10 cents times the number of dimes he has plus 25 cents times the number of quarters he has is his money, okay? And his money, according to the problem, is $3.75. But since I didn't use decimals over here, I'm not going to use a decimal over here. That's just going to make it a little easier on myself that I don't have to worry about a decimal, okay? There's your two variables. There's your two equations. You decide how to solve it. Substitution would be nice here. You can also use elimination, however you decide, but you solve it, pause the video, turn it back on, see how you did. I went with elimination again, and I got that there were 9 quarters and 15 dimes. Notice you can check these. 15 times 9, or not 15 times 9, 15 plus 9 is 24. He has 24 quarters. If I multiply the dimes by 10 cents, I get $1.50. This is just my check. If I multiply the quarters by 25 cents, I get $2.25, and when I add those together, guess what? He's got $3.75. This is just a check. You don't have to do that, but you can look and see if you got it right. Okay, let's try another one. Now, this one's pretty straightforward. The cost of admission to the Spring Carnival was $50 for a group of 9 children and 2 adults. The admission was $61 for another group of 10 children and 3 adults. What was the admission price for each child? What was the admission price for each adult? First off, I want you to pause the video. I want you to tell me what your two variables are, and I want you to write the two equations. Then check that before you move on. This is what I got. I let C be children and A be the adult tickets. 9 children and 2 adults gave a price of $50. 10 children and 3 adults gave a price of $61. Okay? I want you to now solve this system. Any method you choose. Looks to me like elimination's probably going to be the way to go, but do whatever makes you happy and then turn it back on and check it. Okay, you can see how I solved it. You may have gone about it a little differently, but we still should have gotten the same answer. I should have put up here when I defined my variables, these are ticket prices, okay, because we're wanting to know the price of admission. So I got a child ticket is $4 and an adult ticket is $7. If you didn't get that, see if you can fix your work and get it to work that way. All right, this last one is probably the weirdest looking one of the ones we're talking about, okay? It says the larger of two numbers is 9 more than twice the smaller. The sum of the numbers is 3 less than 5 times the smaller. Find the numbers. So what are our two variables? What are the two things we need? Well, we need a larger number and a smaller number. I would use X and Y here just because, so I'm going to let X be my larger number, and I'm going to let Y be the smaller number. Okay? All right, now what we're going to do, you see the two sentences here. we are going to translate these two sentences. We did this a long time ago when we looked at equations and word problems, but now these are going to have two variables. They're going to use the x, they're going to use the y, okay? The first one says the larger of two numbers. Well, which one is the larger? X. So guess what I'm going to write? X. The larger of two numbers is, how do I translate is? Equals, right? Now, 9 more than twice the smaller. How do I do twice the smaller? Well, if the smaller is y, twice the smaller is going to be 2y, and 9 more than that is going to be plus 9. So this is the larger of the two numbers is 9 more than twice the smaller. You could also flip-flop those since it's addition. Okay, that would be all right. So there's equation 1. Now, equation 2. It says the sum of the numbers. Well, how do I find the sum of x and y? I add x and y, right? The sum of the numbers is, that's going to be my equals. Now, be careful here. We haven't talked about this in a while. 3 less than 5 times the smaller. Well, we know less than is subtraction, but it's also a turnaround word. Remember that? We have to flip these. So 5 times the smaller would be 5y minus 3. 3 less than that. Okay, so look at the words again. The sum of the numbers, x plus y, is, that's my equals, 3 less than, that means I have to do minus 3, 5 times the smaller, 5y. Okay, now look at this. This system looks a little weird, doesn't it? But I notice x is isolated. So x is isolated, so I can substitute this in here. So try to solve this using substitution. See if you can find x and y, then turn it back on and see if you got it right. Okay, so I use substitution. Notice when I did that, I got a variable on both sides. You guys know how to handle variable on both sides. I solved, I got y is 6. I plugged it back into my isolated equation, and I got that the smaller number, no, I'm sorry, the larger number is 21. I had already found that the smaller number was 6. Okay? See if you can get that to work out. If you can't, write any questions down. We'll do practice with word problems in class.